Good morning, everyone. Am I audible?
Yes, ma'am.
Okay. Okay, so last class, I think we have completed about the uh, this wait. Okay, so last class we have completed about your trickling filters, right? So today we will go through your after your trickling filter, we have your this activated sludge. Okay, we have activated sludge process. Today we will discuss about this. Okay. So basically, your activated sludge process, it is your it is also a process of your secondary treatment process. Okay, like we have a treating filter we have learned, that one also was your secondary treatment process, and this one is also your secondary treatment process. Okay, but the aerobic or one is suspended and one is attached. Okay, the microorganisms, those are one is attached to the media and one is suspended. Okay, the difference we have learned in our next classes. In our previous classes we have already learned. Okay, so this activated sludge process. Okay, so it let us read. Okay, line by line we will read and understand better. Okay, you see, the activated sludge process, it provides an excellent method of treating either raw sewage or more generally the settled sewage. The sewage that is the sewage effluent from the primary sedimentation tank is thus normally utilized in this process is mixed with 20 to 30% of own volume of activated sludge, which contains a large concentration of highly active aerobic microorganisms. So here, so whatever sewage effluent you got from primary sedimentation tank, so that sewage effluent, it is, that sewage is utilized. It is utilized in this process and it is mixed with what? 20 to 30% of its own volume of activated sludge. Okay, so this activated sludge, what it contains, it contains a large concentration of your highly active aerobic microorganisms. Okay, so in simple language, if I tell you that is that this activated sludge process, what happens here, the microorganisms are present in a, like there is an aeration tank and the oxidation of microorganisms, they take place in the presence of oxygen. Okay, so in simple language, that is the main working principle of an activated sludge process. Okay, so the microorganisms, they get oxidized, okay, by the organic matter in the presence of oxygen, and then the effluent from that aeration tank, it is sent to a, like secondary settling tank. There is one secondary settling tank, and in that tank, there are in the bottom of the tank, some sludges are produced, okay, or sludge is formed. So that sludge, it is known as your activated sludge. Okay, so let us read it more nicely here. Okay, so here we have told that the effluent that we got from the primary sedimentation tank, that is, mixed with the 20 to 30% of its own volume of what? Activated sludge. Okay, so this mixture, okay, that mixture, it enters an aeration tank. As I just now I told, there is one aeration tank, and this mixture, okay, the sewage effluent and the mixture of the sewage effluent and the activated sludge, it enters a aeration tank, okay. And where in that aeration tank, what happens, the microorganisms, okay, and the sewage, they are mixed very nicely, okay. The microorganisms and the sewage, they are mixed very nicely, and in the presence of what, in the presence of air, okay. And for about 4 to 8 hours they are constantly being mixed, okay. So under these conditions, okay, under these conditions, the moving organisms, or you can say the microorganisms, the moving microorganisms, they will oxidize. Okay, they will oxidize the organic matter that is present in the sewage. Okay, and this suspended and the colloidal matter, and the in the tank, okay, in the tank, the suspended and the colloidal matter, they will coagulate and they will form a precipitate, okay. They will coagulate and they will form a precipitate, and that precipitate, it will settle at the bottom of the septic tank, okay. So after that this precipitate, it settles down, so that settled sludge, it is like known as your activated sludge, okay. And a part of that activated sludge, it is then again recycled, okay. It is again recycled and it is taken or it is taken back to the aeration tank, okay. It is a part of the activated sludge, it is again taken back to the aeration tank and it is mixed again with the sewage that is being treated, okay. So a part of it is taken back to the aeration tank and some part it is being disposed of in the river stream and all, okay. So this new activated sludge, it is being, like continuously produced by this process. It is like a portion of it is utilized and it is sent back to the aeration tank, and some portion, or you can say the excess portion, it is disposed of properly along with your like primary treatment. It is disposed of, okay, in the river stream and all, okay. So now the effluent, okay, the effluent that is obtained from the activated sludge plant, it is of very high quality, okay, and it is having a very low BOD than that of a what, trickling filter plant, okay. The effluent that you got from a trickling filter plant, okay, so that is having a little bit of higher this higher amount of or higher percentage of BOD. But here in the activated sludge process, what happens, the BOD, it is generally low, okay. And the BOD removal here, it is up to 80 to 95%. Okay, BOD removal in activated sludge process is 80 to 95%, and the bacterial removal is up to 90 to 95%. That means you can assume or you can imagine how much of accurate results this process is giving. Okay, so here the bacteria removal is up to 90 to 95%, and also here the land, the area of land that is being used, it is also very less, okay. The land area required for this activated sludge plant is also very less, and in this process what happens, uh, some operations are necessary, okay. Like it is written here, a rather close degree of control is necessary in operation to ensure. So here degree of control is very necessary in operation. For what? Because there is an ample supply of oxygen is present, because this process or this treatment process is done only in the presence of oxygen, okay. And that there is intimate and continuous mixing of the sewage and the activated sludge. So there you have to control in the operation process, it should be in a very controlled process, because there is an intimate and continuous mixing of the sewage and the activated sludge. And number three is what, the treated is kept the ratio of the volume of activated sludge added to the volume of sewage being treated is practically constant. Okay, so now there are like different operations and units of an activated sludge plant. Okay, there are different process and units of an activated sludge plant like um, I will show you. This is the flow diagram. Okay, this is the flow diagram for a conventional activated sludge plant giving high degree of treatment. Okay, so all these things we have learned, like from the first one is screens and grid chamber, then primary sedimentation tank, and after that there is one aeration tank, and from the aeration tank it is coming a secondary sedimentation tank. Okay, so this part is your activated sludge plant. Okay, this part is your activated sludge plant. So there are different units or portions of a activated sludge plant. Okay, so next is here like in this process. Okay, in this process uh, this grit removal, screening, okay, and primary sedimentation, those three are considered very necessary for your activated sludge process. Okay, for a conventional activated sludge process, this grit removal, screening, and primary sedimentation are considered very important and very necessary. Okay, and in this process it is, you know, it is very important to keep the sewage very fresh. Okay, it is important to keep the sewage as fresh as possible, or you could say that the detention period is also provided in the primary sedimentation tank. Okay, and this primary detention, it may vary with the size of the plant and the characteristics of the sewage. Okay, and what is the overflow rate of a activated sludge plant? It is 40,000 liters per square meter of plant area per day. Okay, and the depth is about 2.4 meter, and the detention time is about 1.4 hours. Okay, this thing you can remember. This overflow rate, it is 40,000. Okay, the depth is about 2.4 meter, and the detention time is about 1.4 hours. Okay, so before going to the next part, I would like to show you one video. You will see the video nicely. You will see the working principle of an activated sludge process. Then you will, I think, you will understand something a little better. Okay, so I am sharing the screen. Just wait.
A molecular biology method, PCR, provides efficient and specific amplification for nucleic acid.
Activated sludge is worldwide the most used suspended growth process in wastewater treatment. The treatment process can include different steps, but most commonly are screening and grit removal to filter out debris, primary clarifier for particle sedimentation, biological treatment with activated sludge consisting of an aeration basin, secondary clarifier, and recycle stream, disinfection for final removal of germs and bacteria. Wastewater entering the aeration basin still contains organic matter such as food waste and fecal. Microorganisms in the raw water influent will colonize in the aeration tank and metabolize organic waste to ATP for further cell growth, as well as CO2 and water. As the microorganisms need oxygen to survive, the tank is aerated, for example, with diffuser systems. The amount of oxygen needed for biochemical processes is also known as the BOD value. BOD is a very important indicator for the level of wastewater pollution. To keep a good balance between the number of microorganisms, organic waste, and oxygen, some microorganisms are settled down in the secondary clarifier. Adding flocculants will cause that microorganisms will clump together with particles and settle down as activated sludge. Some of the activated sludge is then recycled back to the aeration basin, whereas the rest is removed as waste sludge, thickened, and then, for example, used as fertilizers. By recycling the activated sludge back into the aeration basin, the amount of microorganisms can be increased significantly, e.g. 30 times compared to the raw water influent. This is exactly the principle of activated sludge, to accelerate biological degradation significantly in a confined space. The sludge recycling rate does not only affect the sludge volume, but also the sludge age. Young sludge, 2 to 8 days, refers to microorganisms that metabolize organic waste as described before. Instead, older sludge, older than 8 days, is used for nitrification processes to oxidize ammonium, NH4+, to nitrate, NO3-. The sludge age can also be expressed as the SRT, solid retention time. The SRT is the volume of the reactor multiplied with the concentration of solids divided by the excess sludge. The number of microorganisms present in the aeration basin, and therefore the treatment capacity of an activated sludge plant, is limited. The ratio of microorganisms and waste stream is also known as the MLSS, mixed liquor suspended solids concentration. As higher the MLSS, as less volume is needed to remove BOD from the waste stream. The maximum MLSS concentration for activated sludge basins is about 3,500 milligrams per litre. However, by adding fixed film media into the aeration basin, also known as IFAS systems, the MLSS can be increased by up to 5,000 milligrams per litre, meaning the treatment performance can be increased by up to 50%. Please click on the following video link to see in detail how the activated sludge process can be upgraded with fixed film media systems. Thanks for watching, and if you like our 3-minute tutorials, please subscribe and don't forget to give a thumbs up.
Okay, so you have watched the video. I think now it's a little bit of clear. Okay, just wait. Okay, so you have seen the process or whatever I explained. It was shown in the video. Okay, so now. hmm, Okay, so the aeration tanks, okay, we will study the methods of aeration. So, what are the methods of aeration? So, like it's written here, you see, from the primary sedimentation tank, the sewage it flows to the aeration tank and it is mixed with the activated sludge. Then the aeration tank, okay, they are normally rectangular in shape, or you can say they are rectangular tanks, and they are 3 to 4.5 meter deep. Okay, and it is 4 to 6 meter wide, and the length range is between what 20 to 200 meter, and the detention period it is between 4 to 8 hours for municipal sewages. Okay, so you can underline, or you can later remember this values. Okay, it is 3 to 4.5 meter deep, 4 to 6 meter wide. Okay, length ranges between 20 to 200 meter, and detention period is between 4 to 8 hours for municipal sewages. So what are the different methods of aeration? The different methods of aeration, you see, those are, so there are like two basic methods for introducing or for putting the air into the aeration tank. So what are those methods of aeration? That is, number one is your diffused air aeration, or it is also known as air diffusion. Okay, and number two is your mechanical aeration. These two are the main, but sometimes also you can find the combination of both the diffused air and mechanical aeration, which it is together known as your combined aeration. Okay, so, let us study something about the diffused air aeration. So, in the diffused air aeration method, your compressed air is introduced into the aeration chamber, and what under pressure of, there is a pressure that is your 35 to 70 kilonewton per meter square. Okay, through diffusion plates or other devices. So there are some diffusion plates or like other devices called diffusers. Okay, through the diffusers, your air, or sorry, compressed air, it is introduced into the aeration chamber under a pressure of what, 35 to 70 kilonewton per meter square. Okay, so the main criteria or the main condition for selection of a particular diffuser is what? It is that it should be capable of diffusing air in small bubbles. Okay, so the main criteria is that the diffusing, okay, it should be able to diffuse the air in small bubbles, okay, so as to provide the greatest possible efficiency of aeration. So like if it diffuse the air in small bubbles, so it gives like the best aeration process. Okay, it gives the best possible efficiency for aeration. Then again, your porous plates and porous tubes made of quartz or crystalline alumina are generally used as your diffuser. So what is the material used for your diffusers? It is your porous plates and porous tubes. Okay, what is it is made up of? It is made up of quartz or crystalline alumina, or it's also known as your aluminium oxide. Okay, so those are used, these materials are being used for your use in your diffusers. So these plates, these are generally these are square in shape, and also it has a dimension of what, 30 centimeter by 30 centimeter, and they are 25 thick. Okay, so these dimensions are given about the the whole tank or the whole diffuser thing. These dimensions are given. Okay, you can see then that these plates or these tube diffusers, these are generally 60 centimeter long. Okay, all these things you can study by yourself. Okay, what are the these dimensions and all you can study. So like number one, the main thing is that here in diffused air aeration, your compressed air is introduced into the aeration chamber. Okay, like, and what is the pressure? It is 35 to 70 kilonewton per meter square. Okay, so now, okay, so in the mechanical aeration, let us see what is there. So in the air diffusion method, as pointed out above, a lot of compressed air gets wasted as it simply escapes through the tank without giving oxygen to the sewage. Okay, although it helps in bringing about the required agitation of sewage mixture. Okay, so what happens in your air diffusion method is that here a lot of compressed air is given, and also a lot of compressed air it gets wasted, because this waste or this compressed air it gets it escapes, okay, through the tank also without giving oxygen to the sewage. So here in this this sorry, mechanical aeration. So if while mechanical aeration is done, okay, it is in order to affect the economy, or atmospheric air, it is brought in contact with the sewage in the mechanical aeration method. So in this method, the sewage, it is being stirred up by means of mechanical devices. Okay, so mechanical devices, like there are paddles. Okay, paddles, or also it is known as your surface aerators. Okay, so these paddles, they are being used in order to introduce the air into it from the atmosphere. Okay, by continuously changing the surface of sewage by the circulation. So there is a, constant circulation of sewage from bottom to top. Okay, so I will, let me show you, there must be one diagram, let me show you. Okay, this one you see. So these are pedals. Okay, these pedals, they are constantly changing the direction, and through, with the help of this mechanical pedals, so what happens here, your air is introduced in the uh, tank. Okay, okay, then, okay, so your this mechanical air, diffused air aeration and mechanical aeration we have studied. So next is your, actually all these things, for you, no need to go in very depth. Okay, so you should know, for your later in elective subject, yes, you have to go in details then, but now you should know the, what is activated sludge, okay, how the process works, all those things you should know. Okay, the names also you should know. Okay, okay, then, okay, so there are like certain, you can say, design considerations that is involved in activated sludge plant. Okay, so there are certain design considerations, and those are what? Like number one is your aeration period. This aeration period, it is also known as your hydraulic retention time. Just now in the video they have told about all these things, but let us see about the formulas and all. So your first one is your aeration period, that is your hydraulic retention time, and in short it is written as your HRT. Okay, and okay, let us see what is HRT. So it is like, the formula is your volume of the tank divided by rate of sewage flow in the tank. Okay, so the aeration period, it tells about the loading rate at which the sewage is applied to the aeration tank. Okay, it empirically decides the loading rate at which the sewage is applied to the aeration tank. So you see here, this is the detention period formula. Okay, this volume of the tank, that is in V in meter cube, and rate of sewage flow in the tank is Q in meter cube per day. Okay, so it is V by Q day. So if you convert it to hours, so it will be multiplied by 24. Okay, so this is the formula for your the expression for your aeration period, or HRT, that is your hydraulic retention time. Okay, number two is your BOD loading, or volumetric BOD loading. Okay, so volumetric BOD loading, it is your like another loading parameter or design consideration, okay, which is used, or which is defined as BOD5. BOD5, that is, BOD5 means what? BOD at 5 days. Okay, the BOD5 load applied per unit volume of aeration tank. Okay, so this is your, this you see, the expression you see, mass of BOD, mass of BOD applied per day to the aeration. Okay, mass of BOD applied per day to the aeration tank is equal to what? Oh, sorry, mass of BOD applied per day to the aeration tank through influent sewage. Okay, divided by volume of the aeration tank in meter cube. So this is your formula. This whole thing is your formula. That is, it's also written is Q into Y naught divided by V. Okay, what is Y naught? Y naught is your BOD 5 in milligram per liter. Okay, Q is the sewage inflow or sewage flow to the aeration tank, and V is your aeration tank volume. Okay, V is your aeration tank volume. So this is about your volumetric BOD loading. So how much of BOD it is being applied or per unit of the aeration tank. Okay. So now next is your food to microorganism ratio. That is, you can also say as FM ratio. Okay, FM ratio. So it is like it is an important rational organic loading rate adopted for an activated sludge process. Okay, it is a manner of expressing BOD loading with regard to the microbial mass in the system. The BOD load applied to the system in kg or gram is represented as food, and the total microbial suspended solids in the mixed liquor of the aeration tank is represented by M. So this F by M or FM ratio, it tells you about the what it BOD loading. Okay, BOD loading in regard of what? By microbial mass in the system. Okay, so this is your formula. This formula you say daily BOD load applied to the aerator system in gram divided by total microbial mass in the system in gram. So these formulas you have to remember. Okay, there is no particular numerical. We will not do any numerical related to this, but your in short notes or later if any physical classes will be physical exam will be there, then you there might be some short notes regarding your food to microorganism ratio or the design considerations of your activated sludge process. Okay, so then last one is your like sludge ratio, sludge age. Okay, this sludge age, it is like it is an important operation or it is an important parameter related to the FM ratio. Okay, it may be defined this sludge age it may be defined as the average time for which particles of suspended solids remain under aeration. So it gives you the average time. Okay, it gives you the average time for which the particles of the suspended solids it remains under aeration. Okay, so it does indicates the residence time of biological solids in the system. So you just remember that with this sludge age, it gives you the average time for which the particles of the suspended solids it remains in the or it is under aeration. Okay, so okay. So, there are some a question might be asked like this that between your activated sludge process and trickling filter process, okay, which one would you prefer and the choice of one. Okay, which one would you prefer? So like this question also might come, or like what are the advantages of activated sludge process over trickling filter process? Okay, the same thing, same question is there. So you have to know the advantages and disadvantages also of your activated sludge process. Okay, so you see here, so what's written that the conventional biological treatment of sewage, it is usually carried out either by trickling filters or by using an activated sludge process. So two processes we have studied in your secondary treatment. Okay, one is your attached and one is your suspension. Which one is attached and which one is suspension? So suspension is your activated sludge process and attached one is your trickling filter one. Okay, so the basic difference between an activated sludge process and the action involved in the trickling filter is that whereas in a trickling filter the bacterial film coating the grains of the filter media is stationary. Okay, like now I told you, and likely to become clogged after some time. So it is attached, and the filter media, it is the medium of the like filter, it is the bacterial film coating the grains of the filter media, it is stationary. Okay, and also this might get clogged after some time. And in the activated sludge process, what happens on the other hand, the finer suspended organic particles of sewage are themselves coated with the bacterial film, which is kept moving by the constant agitation. So here you're in presence of air, so the whole thing, the whole this bacterial film or the this microorganisms, they are kept moving in the constant agitation. Okay, so in the activated sludge process, the sludge blocks are coated with bacteria. Okay, and they act like free moving organisms. Okay, and which are being continuously swept through the sewage, and which in their search of food and work oxidize the organic matter present in the sewage in a much more efficient way than the carried out in a filter. Okay, so here like basically this thing we have already just now we have explained. Okay, the same thing is written here, so they have just make it like for a like a difference thing. Okay, they have made a difference one. So here you can write out the, you can pick out the important lines and you can write it down. So like difference, you should write in points. I would prefer that you will write in points. Okay, so here these points are given. Okay, this you see advantages offered by an activated sludge plant. So five points are given, then again disadvantages are also given. You see here in point it is written. Okay, 5 points you have, you can write it from here. Okay, 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 5 minutes. Okay, so your treatment process is basically it is finished. Okay, but some this septic tank and some oxidation codes, all these are left that I can finish in one class. Okay, Monday, Wednesday. Okay, so Wednesday I will finish your treatment process. Okay, after your treatment process, basically your module 2 it might be finished. Let's see, I have to see the syllabus. Okay. Okay. I forgot to bring the attendance sheet, so I will write down the roll numbers. Okay, I will. You just tell me those who are present. Okay. Roll number 1 is present.
Ma'am.
Okay. Roll number 1, 2,
Yes, ma'am.
3,
Present, ma'am.
4,
Present, ma'am.
5, 6, 7, 8, 9, 10. 9 is present. Okay, 9, 10, 11, 12,
Present, ma'am.
12. Okay, 13.
Yes, ma'am.
Okay, 14, 15, 16, 17,
Present, ma'am.
17, 18.
Yes, ma'am.
18 is present.
Yes, ma'am.
Okay, 18, 19.
Yes, ma'am.
Okay, 20.
Present, ma'am.
Okay, 21, 22,
Yes, ma'am.
22, 23,
Yes, ma'am.
24, 25,
Present, ma'am.
25, 26.
Present, ma'am.
Okay, 27, 28,
Ma'am.
28, 29, 30,
Yeah,
Present, ma'am.
30 present. 29 is present or what?
Yes, ma'am.
Okay. 29, 30, then 31,
Absent.
32,
Present, ma'am.
okay, 33,
Yes, ma'am.
34, 35, 36, okay, 34 is present, 34,
Yes, ma'am.
okay, 35, 36, 37, 38, 39, 40,
Yes, ma'am.
okay, 40, 41,
Present, ma'am.
42, 43,
Present, ma'am.
okay, 44, 45, 46, okay,
Yes,
45
ma'am.
present, okay, 46 present, 47, 47, 48, 49, 50. Anyone is left out? Roll number 11. Okay, then anyone else? 40. 40. I have given. Baby Michelle, I have given present. Next. Anyone else left out? Okay, then I think no one is left out. Okay, then